Good day everyone. So we are going to discuss about clouds, fogs, and different forms of precipitation. Okay, so let's start. Now let's first define what cloud is. Okay, cloud is a visible aggregate of minute water droplets and or ice crystals that are suspended in the atmosphere above the Earth's surface. And also it provides a visual indication for meteorologists about atmospheric conditions. So what different types of clouds will tell us different types of atmospheric conditions. Okay, so now let us discuss how clouds are formed. Now we have here rising warm parcel of air because we have, of course, the evaporation process wherein water surface is heated, then it will evaporate because hot air and also hot parcel of air rises, okay? And then after that, since it has evaporated and it's also moving to a higher altitude, what happens at the higher altitude is that there is now the adiabatic cooling process. Let us recall what is an adiabatic cooling. When we say adiabatic cooling, that means no heat is added or removed from the system. However, what happens there, as it moves higher to the altitude, we know that the pressure there decreases. So, pag nag-move siya higher, then pressure decreases, so it will actually expand. Because if there is so much pressure, the air parcel or the parcel of air should be squeezed. But the pressure decreases, so somehow it expands. Kasi there's no longer the pressure holding it. So it will just expand, and as it expands, it will cool down. So that is what we call adiabatic cooling process. So it will start to cool down until it reaches the what we call the dew point temperature. So it will reach that dew point temperature at a level we're in. That is, the term that we use for that level is the condensation level. So the condensation level, when it has reached its dew point temperature already, so it will start to condense. But take note also that condensation or the formation of clouds has two more requirements. One is that the air is saturated and also that there should be condensation nuclei. So ano yung condensation nuclei? This could be particles or this could be a surface where the water droplets can be attached. So if there is a condensation nuclei and the air is saturated, then clouds are formed. But in the absence of condensation nuclei, pwede pa rin mag-form ng clouds. However, it will only form if the relative humidity is higher than 100%. So the saturation point really would be higher, or the relative humidity is greater than 100%, even though there's no condensation nuclei, then clouds will form. We also have a category for condensation nuclei. So here are the explanations, so you can read it. When water vapor condenses in the atmosphere, again, it's due to adiabatic cooling. And then parcel of air moves to the higher altitude, there will be low pressure, okay? So I already explained this one. And we have this at the lifting condensation level. So it will cool down to its dew point temperature. Then it will start to condense if, again, the air is saturated and then there is condensation nuclei. Okay? So condensation nuclei can be microscopic dust, smoke, or salt particles. Now, as I have mentioned, we have two categories for condensation nuclei. One is hygroscopic, or we know this one as water-seeking nuclei or water-loving particle. These are examples, or our examples for that would be salt particles, dust storms, or dust storms, and pollens. Then we also have this what we call hydrophobic or water-repelling nuclei. So it doesn't want water. They are not efficient condensation nuclei. So the efficient condensation nuclei would be the hygroscopic. But cloud droplets will still form if, again, the relative humidity is 100%. Cloud droplets may have different or various sizes because of the affinities of condensation nuclei, the affinities to water. Now, I'll show you an example of a hydrophobic or water-repelling particle. Okay, so this is just a very simple demonstration on a hydrophobic. So this is known as aqua sand. So if you can see it, so this is just sand, but of course it's covered by a material wherein this one is a hydrophobic. So let's take a look at this demonstration. Okay, I hope you can see this one. Okay, so you can see here, we already have the particles inside. Yan, baka mabasa ang aking laptop. So you have here the particles inside. So as you can see, ulitin natin. Okay, so we have here an example of hydrophobic particle. So let's pour. So let us pour more sand. So this is known as aqua sand. Okay, there. Then you can see here inside the water. So it has formed like that. But if I will try to get this one, again, so inside the water, you can see this one. Yeah. But when I remove it from the water, so there. So that this one again is known as a hydrophobic material or a hydrophobic sand. So it doesn't love water. So this one is known as a hydrophobic sand. It doesn't love water, so it's not attracted to water. That's why it's not a very efficient condensation nuclei. Okay, so now let's talk about the different cloud formations. So you have here different types of clouds. I know that in elementary you were able to discuss some types of clouds, but we are going to have more definition. We are going to have more classifications of clouds at this point. So you can see here the types of clouds. You have cirrus, stratus, cumulonimbus, cirrocumulus, and altocumulus. So different level or different heights, we have different classification of clouds. Okay, you can see here another illustration about clouds wherein we have at low level, so it is less than 2,000 meters. But in between 2,000 to 6,000 meters, we have the middle clouds. And then above 6,000 meters, we have the high clouds. So here are examples. You have for the high clouds, we have the cirrocumulus, cirrostratus, and then cirrus clouds. Then for the middle level clouds, we have altocumulus, altostratus, stratocumulus clouds, and then we also have this vertical developing clouds or vertical towering clouds like cumulus clouds and cumulonimbus clouds. And then we also have the low clouds. Then we also have the low clouds, the stratus clouds, and the nimbus stratus clouds. Okay, so let's take a look at them one by one. The one who named this classification of clouds would be Luke Howard, an English naturalist who published cloud classification. He classified clouds on the basis of form and also on the basis of height. Now, as you can see here, we have cirrus clouds. So they are high, white, and then thin clouds also. They form like veil or patches of feathery in appearance. So if you are going to look at the sky and then you can see this pattern, that is cirrus cloud. So it has para siyang may mga feathers and filaments. And again, it's considered to be a high cloud. Then you also have the cumulus clouds. Clouds consist of globular cloud masses that are often described as cotton-like naman. So this is a very famous classification of cloud, the cumulus cloud. They exhibit a flat base. However, they can tower up or they can develop in towers. So they can pile up. So that is cumulus clouds. Then we also have a general classification of cloud, which is the stratus clouds. So they are best described as sheets or layers. Para ano siya? Uniform sheet siya or uniform layer that cover much space in the sky. So there are no distinct individual cloud units. So yan, malaki yung coverage ng stratus clouds. Then I want you to look at this. These are considered as high clouds. We have the cirrus clouds. As I have mentioned, they are formed as filaments para siyang may mga feathers. And then you also have the cirrus stratus clouds. It's still a high cloud, so it's still above 6,000 meters. That's why the term you have there, cirrus. So that cirrus stratus, the coverage again, parang uniform siya na nako-cover yung sky. But you can see there, thin lang yung coverage niya. So you can no longer see partial units of clouds. That is cirrus stratus clouds. So sometimes you can see yung mga formation ng halos. So that can happen when you have a cirrus stratus clouds. Then you have here cirrocumulus clouds. So it's still a high level. However, patches ng cotton-like structure. So that is cirrocumulus clouds. They are also known as mackerel sky. It's like it appears to have mackerels in the sky. So you can see here, middle level, we attach the term alto. So now this time you have altocumulus clouds and altostratus clouds. So since they are located at the middle level, that's why we attach the term alto. So cumulus, because you can see here in the illustration on your left, in the illustration that you can see on your left and on my right, that is altocumulus. Kasi it appears to be cotton-like structure. However, they are found at the middle level in between 2,000 to 6,000 meters. And then the next one would be the altostratus clouds. Again, there's no visible parcel of clouds. It's just a full coverage of clouds. And it's the middle level. That's why it's known to be altostratus cloud. Okay, one of the low-level clouds is also the nimbus stratus clouds. The term nimbo is attached if it's low level. So you have the nimbus stratus clouds. So you can see here, para na siyang uulan. So it appears to be, so it's like before it rains. So we have the nimbus stratus clouds. It's a very low level and also full coverage of clouds. Then you also have clouds which are formed vertically, or yun mga develop into towers. So you can see the first one would be the cumulus clouds. So it's also considered to be at high level. The base is flat. Then there is a piling up of cloud patches. It's like cotton. Then you also have the next one would be the nimbocumulus clouds. Then the next one would be the cumulonimbus clouds. So it's a very low level cloud. It's low level. However, ganun din, the base is flat, but there is a towering or piling up of cotton-like structure. But it's at the low level. Yeah, the cumulus clouds, the one on your left, you can see here, the cumulus clouds could be associated with fair weather conditions. But the cumulonimbus clouds cannot be associated with fair weather conditions, but it's in a rainy condition or malapit ng umulan if you have cumulonimbus clouds. Okay, so we also have this one example, lenticular cloud, wherein it appears to form a lens. Okay, so it happens in mountain ranges where there is a turbulent flow also of air. So that is lenticular clouds. So here is the summary for the different cloud formations or different cloud classifications and their characteristics. So it's according to the height and also dun sa appearance nila. Okay, so you can review this summary. Okay, so now let's talk about fog formation. But what is a fog? It is a cloud with its base at or very near the ground. So that is the main difference between cloud and fog. Okay, we know that clouds are formed at the sky, but fogs are formed near the ground. Fog results from cooling or when air becomes saturated due to the addition of water. So if air becomes saturated due to the addition of water, so that is evaporation fog. Okay, so now let's take a look at different types or different classifications of fog. Okay, the first one is radiation fog. When we say radiation, as we know that the Earth also emits heat, so it will also radiate. During clear skies, it can easily radiate heat coming from the Earth's surface. But because the relative humidity, this can also happen if there is the relative humidity is high. So it will also cool down because of radiation cooling, because nga it emits heat or it releases heat. So once it releases heat, that means it will cool down, and then the relative humidity is also high. Therefore, that surface can reach its dew point temperature. And if it reaches its dew point temperature, then fog is formed. Okay? So that is radiation fog. Further radiational cooling at top of fog layer deepens it. So, pag marami pang radiation cooling, so you will have a thicker fog. Okay, so that is our definition of radiation fog. Then, it also mentions here that it happens during nighttime when the sky is clear, because it can easily radiate energy if the sky is clear. If the sky is not clear, so that heat will just bounce back, or it will just be re-radiated to the ground. So, babalik lang siya. But if we have a clear sky, so it can radiate outside the Earth's surface, so it will cool down. Okay, next example is advection fog. Advection fog will happen if you have colder surface. So this time you have cold surface, but warm air above it pass through it. So there is a warm air, then there's a cold surface, then that warm air will be cooled. If there is enough cooling, then fog will form. It will reach its dew point and fog will form. So that is advection fog. So, yun nga, a layer of warm air becomes chilled by contact with a cold surface which could be found below the warm air. So, that is advection fog. Then we also have here upslope fog. So, if you have a sloping area or a sloping region, we have moist air flows toward the slope, so it will move upward. And then, as I have mentioned, as it moves upward, the pressure decreases. So, there is again adiabatic cooling. So, if the adiabatic cooling happens at the surface or the ground surface, so you will be able to see an upslope fog. Okay? So, of course, it happens in mountain ranges. Okay? So, here is another illustration of upslope fog. Okay, upslope fog, again, in the definition, forms when relatively humid air moves up, sloping, and then again there is adiabatic cooling and it will reach its dew point. Therefore, it will form fog. So this one is an example, another example, but this one is evaporation fog. When we say evaporation fog, there is an addition of water droplets or water. Okay, so another example of fog we have here, steam fog. So this is a type of evaporation fog wherein fogs are formed due to addition of water. So what happens here, we have steam. So at the surface, it's producing steam. It is a hotter surface. And then you have cold air above it. So since may nag-evaporate, that evaporation can actually saturate the cold air above it. So because of that saturation, it will form fog. So that is our steam fog. Okay? So we also have this frontal fog. For frontal fog naman, kanina ang surface natin, the surface below has higher temperature, but this time, the surface below has lower temperature. And then there will be warm air which can pass through it. Okay? So we have here frontal fog. Occurs when raindrops falling from relatively warm air, okay, you have warm air, above a frontal surface will evaporate the colder air below. So, due to that evaporation of colder air, taas may warm air ka sa taas, nag-evaporate yung colder air, again, the air will become saturated and it will form a fog. So, that is known as frontal fog. Okay, again, take note that when we say evaporation fogs, fogs are formed because of saturation of air or because of the additional water or water vapor. Okay, so now let's talk about precipitation. Let's define precipitation. What is precipitation? Precipitation is a liquid or solid water falling from clouds to the Earth's surface or formed on different bodies as a result of atmospheric water vapor condensation. And also, it could either be solid or liquid precipitation. But how does it happen? So let's talk about the process of precipitation. So we have this what we call Bergeron process. Okay, what happens here, the two conditions should be met. It should be forming in the high clouds, and it should also be very cold, below freezing point. So that particular layer of clouds should be at below freezing point. So it should be a tall clouds, mid-latitudes over the continents. Then also at that particular region, the different phases of water can coexist. We can have water vapor, liquid water droplets, and also ice crystals. And then in this process also, ice crystals can grow faster than the water droplets. So that is a Bergeron process. But how does this one happen? Take note also that condensation is actually an inefficient way to have precipitation. So pure water also doesn't just freeze at 0 degrees Celsius, but it has to freeze lower than 0 degrees Celsius. And then if water exists, or liquid droplets of water exist at lower than the freezing point, or that lower than the 0 degrees Celsius, then we can consider that as super cooled water. Okay. In Bergeron process also, there is a net movement of water droplets or liquid droplets into ice crystals. So let's take a look at how this process goes. So take note also that the saturation vapor pressure, so you can compare here, relative to water, that it would be orange, and then your relative to ice would be blue. So the saturation vapor pressure for ice is lower compared to water. So that the surrounding of ice could easily be saturated compared to the one above water surface. So let's take a look at this. As I have mentioned, the saturation vapor pressure for water, as I have mentioned that the saturation vapor pressure for water is higher, so you can see here the gauge is higher compared to the saturation vapor pressure for ice. So if this one has higher pressure, so there will be a movement of the particles from this area to this area, which is considered at lower pressure. So what happens here, there will be a growth or higher deposition of water to solid ice crystals. So ice crystals will grow, then water droplet will decrease. So that is the Bergeron process. So let's take a look at this illustration again. So you have here, the deposition rate is actually higher in ice crystals compared to for the water. So you have here, evaporation rate of water has increased, but the condensation rate has decreased. But for ice crystals, you have here, the deposition rate has increased compared to its sublimation rate. So recall that deposition means it's a phase change from water vapor to solid ice crystals. But sublimation is from solid ice crystals to water vapor. And evaporation is, of course, from liquid to gas. And then condensation is from gas to liquid. So you can see here in letter B, ice crystals or ice crystal grows at expense of shrinking water droplet. Because I have shown in the previous illustration, balikan natin, since mas mataas ang pressure over water, so that particles could move over ice, then there will be deposition. So that water vapor will now be solid ice crystals. Okay, so as you can see, there's a growth in the ice crystal, but there is a shrinking water droplet. So that is the Bergeron process. But what happens, so you have here the formation of ice crystals, but as it moves down, so it will pass through the area 0 degrees Celsius, so it can precipitate as water. It doesn't mean that there is ice crystals here, that it will have a precipitation of ice na agad. So there will still be precipitation in the form of water. So that is about Bergeron process. Okay, so let's talk about another process of formation of precipitation, which is the collision coalescence process, wherein in this process, this happens if you have clouds which is not very cold. So unlike kanina in the Bergeron process, it happens if you have tall clouds which is considerably very cold, below freezing point. But for this one, this happens if you have small, large droplets of or water droplets, and then they will just, as it moves down, it collides with other droplets until it becomes bigger. So if it becomes bigger and heavier, it will start to fall down. That droplet also could split into smaller droplets. Okay? Then we'll have a precipitation. So that is collision coalescence process. Wherein again, the condition is it's not very cold clouds. So what happens is just water droplets will just collide, then it will form into bigger droplets. Now, the next topic that we are going to have would be the different types of precipitation. So let's take a look at different types of precipitation. So first one, of course, is the rain. So rain, they are drops of water that fall from a cloud and have a diameter of at least 0.5 millimeters. So they have to reach 0.5 millimeter before it falls. And most rain originates in either nimbus stratus clouds or in towering cumulonimbus clouds that are capable of producing unusually heavy rainfalls known as cloudburst. And fine uniform droplets of water having a diameter of less than 0.5 millimeters are called drizzle. So, doon na yung ambon, yung very small, yung size ng particle. Precipitation containing very small, then they are also known as mist. So, meron ding mga rain wherein it doesn't actually reach the Earth's surface. So, there is a precipitation wherein as it passes through unsaturated area or unsaturated air, they will just evaporate. That's why may makikita kayong formation. So just like in this illustration, this is known as virga, wherein it's a precipitation or rain which doesn't reach the Earth's surface. Now here is our summary for rain, because rain is in a form of water droplet. So you have mist, if the size is 0.005 to 0.05 millimeters in a form of liquid. Droplets large enough to be felt on the face when air is moving 1 meter per second. Then it's mostly associated with stratus clouds. The next is drizzle. It's less than 0.5 millimeters. It's also in the form of liquid. Small uniform droplets that fall from stratus clouds, generally for several hours. And then we have rain. The size for the rain, we have 0.5 to 5 millimeters, generally produced if you have nimbus stratus or cumulonimbus clouds. That's why, as we have mentioned, clouds can actually tell us the atmospheric condition and will help us predict whether it will rain or not. When heavy yung rain, size can be highly variable from one place to another. Next is snow. Of course, snow is in the form of solid water or ice. Water vapor frozen into ice crystals. They fall from clouds as snowflakes and also lie on the ground as a white layer. So here is an example of snow. Okay, for the formation of snow, the size also varies. Now, if you have very low temperature, wherein moisture content is very low, you will have small particles of snow. But if you have higher temperature, wherein there is an increase in moisture content, you will have a larger snow particles. Okay, so again, the size of snow also varies depending on the surrounding temperature where it is formed. Then we have a slit. Slit is a wintertime phenomenon that involves the fall of clear to translucent particles of ice. So what happens here, you have warm air, then it passes through, you have warm air rising, then you have cold air, then at the lower level also you have cold air. Then as the rain falls, it passes through cold air, or at freezing point, then you will have ice pellets or sleet. So here are examples of sleet. So it appears to be translucent particles. Again, it happens if you have warm air, then merong rain, then it passes through a particular layer which is at its freezing point, so it will form ice. Then we have hail. These are pellets of frozen air that fall in showers. Hail is precipitation in the form of hard, rounded pellets or irregular lumps of ice. Hail is produced only in large cumulonimbus clouds if there is an updraft approaching to around 160 kilometers per hour. So let's take a look at this illustration. When we say updraft, there is a precipitation or an ice crystal, and then there will be updraft. It will move up again, then it will collect supercooled droplets, and then downdraft again, it will collect again supercooled droplets, then up again, collecting supercooled droplets until it becomes bigger. That's why hail, they are lumps of ice, so they are really bigger particles of ice. So yeah, which is very dangerous. So you can see here in the illustration, it can grow as big as that. So ganun ang hail. Then we have rime. Rime, it is a deposit of ice crystals formed by the freezing of supercooled fog. If you have fog, then it becomes supercooled, or cloud droplets on objects, then the surface temperature is below freezing. If, for example, the surrounding temperature is below freezing, and then you have a supercooled fog, then it will start to form a snow, or it will start to form ice crystals or rime. Objects, for example here, pine needles act as freezing nuclei of the supercooled droplets. So it will freeze as it come in contact with the pine needles. Then on occasions when the wind is blowing also, only the windward surfaces of objects can accumulate a layer of rime. So rime is another precipitation in the form of ice. So here is a summary for ice precipitation or precipitation in the form of solid. We have slit, 0.5 to 5 millimeters. They are small, spherical to lumpy ice particles that form when raindrops freeze while falling through a layer of sub-freezing air. Because the ice particles are small, any damage is generally minor. Okay, next, freezing rain. We have 1 millimeter to 2 centimeters thick, produced when supercooled raindrops freeze on contact with solid objects. Glaze can form a thick coating of ice that has sufficient weight to seriously damage trees and power lines. Then we have rime. They vary in size. Deposits usually consisting of ice feathers that point into the wind. These delicate frost-like accumulations form a supercooled cloud or fog. Droplets when they encounter objects which are at freezing point and freeze on contact with the cold objects. Then we have the snow, 1 millimeter to 2 centimeters. Then we have hail, as I have mentioned, they are large particles of ice, 5 to 10 centimeters. And then gropal, where we have 2 to 5 millimeters. They are known to be a soft hail. Okay, so as you can see in the module, I have not placed an activity in the module. What I want you to do now is to create a concept map. So we have two concept maps. Number 1 would be about clouds, and then number 2 would be about precipitations. So again, the outputs for this discussion, we have a concept map about clouds, and then another concept map about precipitation. Okay, so you have to submit it by next meeting. Bye everyone.